So, hello everyone, and welcome to the Ask the Expert session. My name is Monica. I am part of the marketing team here at EDB. I will be your host for today's webinar. I am joined by Jan Karremans, Director of Product Marketing, and Deepanshu Sharma, Director for Support and Remote DBA team here at EDB. Today, you have the opportunity to ask your questions related to Postgres, your current or future projects to our experts. Before we start, a few housekeeping items. This presentation is being recorded. We will be sharing the recording after the broadcast. The lines will be muted during the entire presentation. All your questions can be submitted in the Q&A tab that you find at the bottom of your screen. The session is scheduled to last about 1 hour. In case we don't manage to answer all of your questions, we will get back to every attendee whose question was not answered. And without any further ado, Jan, Deepanshu, over to you.
Thank you, Monica, and welcome everybody to this webinar here. Hi, Deepanshu, thank you for joining us as well this morning.
Hey, Anne.
And I hope you're doing well.
I'm doing well. Hope you're doing too.
Yeah, and I actually just wanted to quickly start off with a little bit of an anecdote, and I think that might even be interesting to you, Deepanshu, as I had a question last week from somebody who actually came in like, you know, they were running Postgres in their organization, and all of a sudden something went wrong, right? The question was more about, you know, you have this Postgres server running, and all of a sudden it stopped with some bizarre error message. She was changing something in Postgres configuration file, and that stopped all of a sudden. And that got me thinking, you know, about the importance of actually having support for Postgres. I don't know if you run into similar things like that, or people just out of the blue start asking questions.
Yeah, actually, it is not quite uncommon for us to have users who are using Postgres for some period of time, and then they start running into the issues. Though one of the common themes which I usually see is Postgres is a very enticing prospect or database to get into, right? It's open source, you don't need to pay anything to get into it. It's easy to use to begin with. You find it pretty easy to start off with. But very soon, when you start to bring or scale up your application, and it is at that point in time where the knowledge or lack of it starts showing up, because most of the people, because of perhaps the cornering of the market by a certain kind of databases, they are used to having knowledge of that corner set of databases. And when they start looking at something which is open source, they find it difficult to find a single source of knowledge, right? So the knowledge is scattered all over because it's being a community, there are advantages to it and disadvantages to it. So that is where they start having a problem. And that is when you really start seeing cracks in your armor, where with the knowledge not being enough to cater to the situations which you find yourself in.
And typically, so if you look at the usage of Postgres specifically for projects that get more important, right? You start thinking about disaster recovery, so backup recovery scenarios. You start thinking about perhaps high availability. There is obviously a lot of stuff as a developer or as a DBA you need to know of internals, etc. Which kind of these areas do you see as the most common for coming up?
So it usually starts off with the problems with scale. So they design an application, perhaps with a bunch of developers, they're having a certain targets which they wanted to achieve. And as soon as they start nearing that target, they start to see performance dips. And then they need to scale it up. Then the obvious answers they arrive at is, say, perhaps increase, increase the shared buffers or some memory parameters or increase the hardware configurations. Those are the normal things which you can usually do. 90% of the information which you do Google about the most famous place to find your information is usually referring to increase your memory, increase your RAM, increase your hardware speed, right? But there is only that much which it can achieve after that. Then the questions become more about what are you doing with the database? What are the questions which you are asking, right? Anybody can write a query, right? But how to ask the right questions, right? How to tune those things to have optimal performance. Maybe not is the first normal form of the database relation which you have gone into might not be good enough. Maybe you have to look at some other way of modeling stuff, right? So those are the kind of things that is the first level of problems which they have. Most of the people which when they go along developing, they look at backups slightly a bit later, because Postgres internally comes with pretty decent tools like PG-based backups for taking backups. It's quite good. But once you start to reach it at scale, that is when you start to see problems, right? Your database has gone to 100, 500 gigs, 600 gigs, a terabyte. It is then that you start seeing the problem with that. And that is the second layer of problems backup. Nobody thinks about restore till they actually have to restore.
Yep. A backup without a restore is like a prayer in a setting, right? So we actually have a question coming in from Gary around is EDB's containerized solution based on Patroni Postgres operator, or did we design or did EDB design its own automation HA solution? Which is actually a very interesting question. Our containerized solution is called Cloud Native Postgres. It is, and as I am director of marketing, you could think he's come up with this kind of cool marketing name. That's not really true. Cloud Native Postgres is called Cloud Native Postgres because it fits in the principles that the Cloud Native Computing Foundation have set forth. And in this case, that means that Cloud Native Postgres, containerized Postgres, as EDB brings it to market, is actually using Kubernetes, the Kubernetes features and functionality to create things like HA, backup, etc. So that's actually not using any of the tooling. And I think, Deepanshu, that might, for you guys, also bring some kind of new interesting challenges, right?
It does. Actually, it is. First, yes, we are using our own set of designs. We are following the standards which are set by the Kubernetes platforms and all. We are keeping it as close to reality as possible, but we are using our own take on how to implement HA. So if you want to try it out and know more about it, there are multiple things inside it. Just like we are also introducing BDR inside the containers, which is for everyone a bidirectional replication multi-master kind of setup. It is going to be included as a part of the Kubernetes solution. So it's a good place to be. Interesting, challenging, definitely for a support team. Yeah.
Yeah, because Postgres heavily depends on its operating environment, right? So in this case, the containerized infrastructure is also the operating environment. So I can just imagine that for you guys in support, but also for users of Postgres, that opens a whole new can of worms for learning about new technologies, right?
Can of worms, no, I would say, because learnings, yes. So one of the things or the beauty about the containers is the standardization which you can do, right? You can basically have a same set of standard methodologies of launching, containing, and using it, so that an environment which is set up at one place, if it runs into an issue and you realize that there might be a better way of doing things, we can make those changes, give it to one place, and then basically push it to everyone else, right? And we are almost doing monthly releases at this point in time, so the improvements are monthly. So any problem which was found, you will be instantly fixed. It will be fixed and released for everyone else at the same time. So there is a beauty to adoption of Kubernetes. Yes, the knowledge part is it's a steep hill initially. And
Yeah, I can imagine. Yeah.
it's kind of surprising. We basically, by the time we have been doing this for almost 2 years, by the time we have, and this is almost the third iteration, if I'm remembering correctly, and we had to change, we had seen 3 changes in Kubernetes. Right. So,
yeah, absolutely. And Gary, I hope it answers your question. So he asked a follow-up question. I tried your solutions using Minikube and it worked beautifully, but I failed to set up EDB Cloud Native in other Kubernetes environments, mainly storage providers. Do you have any tips or tutorials to set up EDB Cloud Native not using Minikube? Thinking of Rancher especially. I don't know if you want to comment on that, Deepanshu.
there is some talk going about Rancher going forward. I don't have the full plans as of yet. I think we would be soon doing an announcement about the other tooling which we are going to be supporting going forward in a couple of months. So there is a discussion going on, but as of now, I am not certain about any details.
I do know that we do have customers or partners actually working currently running cloud native Postgres on Rancher.
Yes.
So that I think would kind of go into the fact what the specific challenges are using the storage providers in this case, where the challenges in Rancher come from, because obviously storage for a solution like Postgres, or well, a solution like relational databases or databases in general in Kubernetes is a very interesting thing, because a Kubernetes or a containerized environment is built to break, and your database is not really built to break, right? It would be a little bit funny if you would have to reload your database after every time a container fails. So that's a little bit, yeah.
Just wanted to add, it's like just quickly. So we did release the documents and revised document for Rancher. I think it is already included on the website. So you can go to enterprisedb.com, Kubernetes/cloud_native_PostgreSQL/quick start. So a lot of documentation has been updated. So I would recommend that please just visit our website. And you will have the quick start guides available for which should help.
Yeah, from what I have at least heard, that is we're gonna obviously officially support most of the generally available Kubernetes-based platforms, including Rancher. But there are these days so many different variations on these management platforms that we're not going to be able to test and certify all of them individually. But as most just very much adhere to the Kubernetes standards, it should actually just work.
If you have any problems, just reach out to us. We will be more than happy to assist you with any problems which you're having. The documentation definitely, as I pointed out, it's already updated. Just have a look at it. In case if you have any questions, just drop us a line. We will be happy to assist you with that.
Yeah, and just continuing on the thought path with containerized databases, it takes me back to a keynote I witnessed in Riga when I first joined EDB, and that's a couple of years ago now, where there was this guy who said, he was working for a company as head of development or something, and this typical thing that happens, he was building an application and this was the eve of the go live, right? And at some point the evening came and he had to set the application up for actually being launched, and it failed miserably, and that kind of got me thinking about containers, because what he said is his CEO called him and said, what happened? Why is my application not working? And you're supposed to launch it. And his remark to the CEO was, well, it worked on my computer. And then for me, the classic sentence came, the CEO said, that's cool, but I'm not paying you to make it work on your computer. I'm paying you to make it work on my computer. And the cool thing about containers is, my computer is your computer, because you can just take the container image and run it somewhere else. And it's actually your computer running somewhere else.
It's actually true. And again, coming back, it's like easy to have, if you have, you can create standardizations of methods of deployment. So that's the beauty of it. And I do like that a lot. So we do have another question. I'm new to EDB. So what and how have EDB extended Postgres from its normal release, or what's special about EDB compared to basic Postgres? Nice question.
Yeah, you want to pick you want to pick it up, shall I?
I'm going to pick up the technical side. You can pick up add to it. Please do that. It's like I'm definitely going to miss out a lot of it. So areas of interest. So a couple of things. EDB is not when we talk about extending Postgres, we are basically adding a layer of compatibility with other databases, which allows for an easy migration from your application, which is already running on one platform, say Oracle at the backend, and you want to move it to a Postgres backend. It's like if you just take it and plonk it on Postgres, 90% of it might not work because the SQL standards which are being followed by Oracle are not exactly ASCII compliant to a large extent, and Postgres understands ASCII compliance. So if you're going to just pick one thing up and plonk it on Postgres, it may not work. A lot of your procedures or a lot of the functions are going to fail. So what we did was that we added a layer which basically translates your Oracle compatible code to talk to Postgres. Now that is a part of the story that we do on the database side. Plus we added additional features like ability to give hints in your queries, right? That is something which is not there, is not directly placed in Postgres. We also enhance Postgres by giving it features to enable users to control the amount of resource a particular query or a particular session can take when doing an execution. So there are a lot of additional features which we have added on top of Postgres, and then we complemented it with the tooling, which basically enhances the experience of working with Postgres. For example, we are working with something called EFM, a failover manager, which is basically a kind of a suite which basically automatically does the failovers in case if there is an outage detected of your master database. We also have our own versions of backup tools like Barman, which again give you features like incremental backups as well as make management of backups and restores from a single point of control, whereas some of the features might not be readily available in the native Postgres environment. We also are heavily invested in contributing to the community itself. The features which we build, we don't keep it to ourselves. We give it to the community as well. So it's a whole ecosystem which we are trying to develop to enhance Postgres and make adoption of Postgres easier, not only to the people who have always been or interested in Postgres and developing on Postgres, but also make it easier for the people who are not from the Postgres universe to come here and still find themselves at home. So that is, in a nutshell, what we do with EBAS or EDB Advanced Server Architecture.
Good. And if you'll allow me just to quickly emphasize one point, specifically the part that EDB, I know it has been and still is perceived as this company that kind of takes Postgres and makes a commercial version out of it. So what at least, which is near and dear to me personally, is to really emphasize, EDB is part of the Postgres community. So that means we help and work with the community to actually just build Postgres. So the same version that most everybody is running, that actually is running in the major cloud providers, that is being used by all of these other companies to build their enhanced products on top of. That same Postgres is being helped build by EDB. We've been doing this since 2004, and that actually also underlines the importance of your department, Deepanshu, because our support, so the fact that we can give SLAs and SLOs on Postgres, actually what we just talked about, helping companies grow and adopt Postgres is actually one of the most important things that we do, I think. And then additionally, we have tools, of which Advanced Server, as you described, is an important one, but also HA and DR and all of those things. Yeah.
Right, bidirectional replication, making it a bit more easier for people to use. So there are a lot of tooling that we are bringing along to make it a bit more palatable to a discerning user, as we like to call it.
Yeah, exactly. And I hope, Goran, that answers your question. You know, from that perspective, I also think that is important if you start looking at a lot of the pace that Postgres is picking up these days. You know, what we found out, companies build applications and those applications get successful. God forbid you all of a sudden get 1,000 users on your application, because then your database becomes important, obviously. But there are also a lot of very big companies working with Postgres, and the fact that it's open source on the one hand is then very cool, but on the other hand, you know, if you're running a mission critical application, you want someone to be there to have your back if something goes wrong. And I think that's an important function that EDB fulfills as well.
Yeah, that is a very interesting area to get into, right? So one of the things which I have usually seen is the vision of the companies when they move into a new technology, right? In our case, it's Postgres. So I'm going to be talking more about on the Postgres side. It's like they are missing the key point of sometimes saying that how do we see it growing, right? And are we skilled enough, or do we have enough backings, enough vendors, or enough knowledge, access to enough knowledge to keep the operation growing, right? And that is where most of the calculations needs to be, right? If you are going to say, even if you are starting small with an insignificant application, but you developed an application, and you would see certain kind of traction which you are seeing. And these days, everyone is moving into a DevOps model. So there is a constant improvement which is being done on the application to make it more palatable. You're adding more features, you're adding more modules, right? But one of the things which the people neglect is like the little thing called database, the small little thing, right? It is usually, everybody is so concentrated about thinking about, oh, let's get the latest version on top of that. Oh, let's get a bigger server for running our applications into.
Yeah,
right? But they very much lose sight that the engine underneath, on which everything, your blinkers of your applications are running, your sign signals, your steering wheel of the application is running, a small little engine, which is actually also responsible for generating the power. You have to look at that. You should have maintenance. You need to maintain that. You need to do maintenance tasks for it. You need to do a cleanup for it, right? Change engine all once in a while.
You touched on a bunch of interesting points there, actually, and that makes me wonder, you know, if we, and it's no big secret, you're a little bit of a veteran also in EDB. You've done this for the first year or something, right? In the past, you know, Postgres, as from the way it's built, it's conceived, is really very much able to work in a DevOps agile environment. Even before it was called DevOps and agile, it already had kind of these qualities. But you see a lot of change in the sense of, you know, organizations start more working with infrastructure as a code, start working in these kind of much more fast-paced application development cycles, but still business requirements. And we see that coming to us with these extreme workloads where we get 5 nines of availability. From your perspective, if you think back a couple of years ago, what kind of changes have you seen in questions you get around infrastructure for Postgres?
So the biggest change which has been there is, first, initially it was the physical machines themselves, right? To move from your SATA drives to SSDs, which happened, and then the evolution of the NAS as a reliable storage, right? Initially, it was kind of flaky. We have to agree to that, right? So then the evolution and the rate levels which the customers need to use, and then there was a basically, I would not say it's an overnight change, but to us, it almost sent within a period of years. If we were hearing 99% of the cases be about the physical hardware. Suddenly, there is 15 to 20% of cloud infrastructure, where the people have suddenly decided that instead of getting a physical machine, it is cheaper to basically deploy, spin up an instance in the cloud and have your infrastructure running off it. So that is the biggest change which we have seen, where the customers are now already having their deployments running in the cloud, or they are planning to move to cloud, and they are looking for a way they can basically do performance to performance, or an apples to apples comparison in terms of performance once they are deployed on a physical machine and something which is on a private cloud, or in an AWS or say Azure infrastructure. Right? So that is a big change which I'm seeing. I think at this point in time, we are fielding at least close to 20% of questions related to databases, be it performance, be it deployment methods, or as well as replication, right? I mean, getting high availability working on the cloud side. So that is something which is really coming along.
That also kind of makes me think. So some of our colleagues have done some deeper dive work on, how can you make a Postgres implementation actually also economically run well on a cloud infrastructure, namely AWS and Azure, with all of these dependencies between memory, CPU power, storage, and where the actual cost factors are. Would you say that you also get like these kind of cloud-based questions, or is it still even more focused on Postgres itself?
It's in relation, basically. It's like, the question is not, the users do not ask about the hardware comparisons, right? So this is my say IO on this particular machine, and how this is the kind of IO which is being projected. It is going to be enough. It is mostly like, my Postgres performance is X here. That is some amount of TPSs which I'm getting on a physical machine. What do I need to do, or what kind of machine which I need to get in the cloud, which can give me the same amount of TPS or even slightly higher, right? So those are the kind of equivalent questions which we are fielding at this point in time. And yes, the comparison studies which some of our colleagues have already published have helped us and guided us in putting out some numbers to the customers. Though the few things which I like to emphasize to the customer is like, we can give you the best advisory in terms of it's like what is going to be the closest infrastructure which is going to be there. But most of the cloud providers, they give you a certain kind of machines, a variety of machines, maybe X2 large or M1X large, M1 small. So they have their own categories of machines which they are going to ready to do. So it will be easier if you ask for an advisory that this is the kind of database which I want, this is the kind of performance which I want, which is the equivalent, say XYZ cloud vendors machine size which I should be using, because that makes more sense. Because the fun thing is, I was reading about this. It's like, don't quote me on this, but from what I read is,
this is being recorded, right?
Yeah, but this is something which is more of a question, right? If I'm wrong, I'm ready to admit. I was reading about this, and the cost of the machine itself, as soon as you start switching to a larger machine on the cloud, the rate difference is much higher than just buying a bigger hardware if you need to upgrade a machine, right? So if you run out of storage on the local machine, you just put in a new hardware, right? Which might cost you X amount of money. But if you have to upscale a machine, the running costs are very different to just upgrading a machine. So the cost factor, the companies which end up having a problem are usually who are not able to estimate the costs involved in running a machine. So the sizing of the machine is something which needs to be taken care of definitely at that point in time. So yeah, that is where our challenge is like getting an advice to the customer, which keeps in view that they do not have to often upgrade, or they get into a machine size which is not exactly right for their needs, and then they end up spending more than what they do.
I think what emerged from the research that CTO office did was that, if I recall correctly, and again I might be wrong, was that storage was one of the most influential factors on the cost of a virtual machine in a cloud infrastructure setup. So that's actually a very interesting thing if you start thinking about that. And
the bandwidth, you pay for the bandwidth. How much data transfer you're doing if you exceed certain limit, right?
Well, that's actually a very true comment. We were doing a POC for a company, and the idea was, we're gonna. It was a proof of concept. So they said, we don't really want the stuff in our infrastructure. So please, can you guys set up a Postgres database? It was in AWS, but in your own infrastructure, and we'll just connect the application that they had running in their AWS infrastructure to the Postgres database running in EDB's infrastructure. And I think for a fairly limited POC, it was actually the bandwidth thing that I think it was like $45,000 per month to run the POC for a couple of hundred users, and that makes no sense. So that is a little bit further to your point.
Yeah, so those are the things which have to be. We have been asked this question. It's like we say, sorry, no estimates. We can't do that. All right, I think we have a question here. Hans is asking, we currently have non-containerized clusters, each having nodes in 2 data centers with CoroSync pacemaker. It's a master-slave setup with pacemaker switching the master in case if the node is not available. Would you say that this is still a way to go, or are there any known disadvantages? No, it's non-containerized cluster. I don't see this is with it's an acceptable setups which the people using Opensource run, and you are having a master-slave setup. It's great. You would be able to do switchover. That is great. The things which you need to be concerned about is like when you are doing monitoring with a pacemaker. I do not know if it actually does the monitoring about how much behind the slave is of the master, right? The lag, which we really like to call it. Because until and unless you are running a synchronous architecture where the commit on the master is going to be available on the slave at all time, you're always going to be having a slave which is some minutes, seconds, maybe if you're not in good luck, an hour or two behind your master. So if you do a failover, you will lose that data, which is not committed on the slave. So you need what you need to check is like if you're using anything like a CoroSync or a pacemaker, rather a pacemaker to do switchover, just check whether it is able to also give a warning to you that your master slave is too far behind. I would not do a failover to it because it's too far behind, right? That saves you from the potential data loss which you have. So that is a disadvantage which I see. Again, I will put it out there. I don't know exactly about the pacemaker's capabilities of monitoring the data lags themselves and making a decision on top of it. Second thing which is there is false failovers, right? How does pacemaker take into account that it can actually avoid a false failover? Say, for example, your database or the machine on which the pacemaker is doing monitoring, there was a network glitch and the pacemaker thought that, okay, well, the master is down and it decided to do a failover. But your application was still able to connect to the database and work on it. And suddenly the application which is running, which is still able to connect to the database and is doing some transaction, and pacemaker decides to kill it and starts something on the slave, you lose that transaction as well. So just look at those factors, look at the capabilities of pacemaker, look at the criticality of the database, look at what kind, how critical your data is, how much you are ready to lose, and then look at that. Yeah.
I'm also not really familiar with CoroSync, but I know that if you want to do things like automatic switchover or failover, having at least 3 members so you can get this quorum, right? To a little bit what you said also, to kind of prevent any split brain scenarios, and so that's at least something important. The fact that it is non-containerized, I think running Postgres in a quote unquote traditional VM setup is still by far like 90% or more of the way Postgres is being run today. So container adoption is going quickly, but I wouldn't worry like, oh, I'm using this kind of ancient technology because it's not yet containerized. No, please rest assured, if you're running VMs, most of Postgres implementations are running VM. And further to your point, I think it makes sense to ensure, how certain do you want to be of this primary standby setup, because streaming replication itself is sufficient for that. So what is your requirement for using the combination for high availability with these two tools? And or do you have domain specific monitoring for Postgres itself? So this pacemaker or ChorusLink, I think, is the monitoring also specifically on the high availability. But what about monitoring for Postgres itself, right?
So that is definitely, I would just like to add to the containerization. Like right now, the way I understand it, and the larger customers are still exploring containerization for production deployments, right? It is not there. It is not like the 10 or 15% of the world is already deploying its runnings in containers. It's not there. It's mostly DevOps, which is better taking the most advantage of developing a new application, because containerization makes testing or giving an application to somebody else to test immediately makes very easy. You can create one container image and just put it to somewhere else, and give it to someone, and he can actually replicate your code and test it. So that is there. Future is unknown. It is just like when VMs were made available on the market. Nobody knew what is its rate of adoption. Right now, hypervisor is the way to go.
No, I remember distinctly in the beginning, nobody really trusted virtual machines. I'm not going to run my database on a virtual machine because I need, disk IO. So the exact same arguments are now being used for containerized infrastructure, right?
Yes. But just still early days, so please be rest assured you're fine. Yeah.
So Gary comes with a very interesting question. Do you have any suggestions for backup strategies for multi-terabyte databases? Yes, I think there are a bunch. The cool thing about Postgres, and Deepanshu will correct me where I'm wrong or augment where necessary. But the cool thing about Postgres is that making backups of these kind of large databases is actually a box of Pandora. There are so many possibilities to do this and so many strategies you can follow, from what we said before. You have incremental backup strategies that you can do, but with Postgres you can also do things like image backups, where the old technology, where you say, I'm going to do begin backup, make a snapshot, and do an end backup, and archive the whole files that belong with that period, actually implement a good enterprise backup strategy. We're actually working with bigger enterprise backup solution providers as well, that really partly implement this technology or any of the other ways and options that Postgres allows you to do disaster resilience for Postgres.
So interestingly, we have been at EDB, we have been very aware of exactly what is needed. So the standard methodologies which are there, which is like base backup, but the one or any technology which we basically leverages PG base backup, which is a single stream copying of data, it becomes difficult to maintain. So 20 terabyte database, if you are taking a backup, it can close. You're using a PG based backup, can easily take up to 10 hours just to move the file from one place to another, and that to on a good network, right? So EDB has been collaborating with a few of our partners, and Veritas is one of them. So we have certified Veritas Net Backup for use with our EDB EPAS databases. So you can definitely look at Veritas technology for looking at doing backups. So there are explorations and extensions which are being made available by NetSuite, and I think there was one more.
Yeah, there are. IBM has something we're
Yes,
working with.
IBM. Exactly. I'm just trying to remember the name of that.
Yeah, well, they changed it a couple of times. It
To
was
change the name, right?
it eludes me.
Repostor, right?
Repostor is another solution that is related to that, but it's an independent vendor. They had this very beautiful name created for their backup solution, our friends at IBM, but I must admit it eludes me at the moment.
Yes. So there are a couple of vendors who are out there, but NetSuite is something which we have definitely worked with for a long time, and we have actually seen it work pretty well. So you can definitely have a look at that.
But especially coming from, and this is true for me personally, because I came from an Oracle background. In some environments, folks are used to thinking about backup and recovery strategies as something you need to do with a tool, right? There, you can't do a backup without a specific tool. And the mindset shift that I had to make when starting to think about Postgres disaster resilience and how you start implementing this is really letting go of that core belief that you need to have absolutely a tool to do this, because basically a backup is in its core, it's a backup of, or it's a copy, I should say, of your Postgres data directory. Postgres adds some functionality to ensure that it's a consistent copy, but in the end, it's a copy. A copy can then be a snapshot, right? That you can make consistent by using begin and end backup and making sure that you have captured the changes that happen to that file image copy in that time that you do the copy. So basically then with solutions, storage solutions like change on write, etc., you can make multi-terabyte copies extremely quickly, because you just say begin backup, I do my snapshot, which takes you a couple of seconds, I do an end backup, and actually from that you can always recreate a consistent copy basically of your database and actually have a valid backup for Postgres done in that sense.
Yep, that is very true, Jan. The couple of things where I usually see the approach with that, right? So for example, it's like VM snapshots, right? The thing which you like put the database in a backup or do a VM snapshot and you're done with it, right? So kind of.
Yeah.
Right? So we have seen people use that successfully, but it has to be tested. You have to be ensuring that you always have the archives available, right? The question is basically to the users, right? Is whether you want when do you need a third-party solution, right? When the tools which are available to you off the shelf within the operating system or the VM environment are not good enough for you. That is going to be the key question, because people who did snapshots, they are very happy with it, right? They say, I got an instantaneous snapshot. But the quite problem is when they have to do a point-in-time recovery, right? I do a snapshot every day, right? Now and somebody deleted a table on the 23rd hour, right? And I need to get the closest, I need to do a point-in-time recovery. Now, when I'm doing point-in-time recovery, the only way which I can do it is restore the snapshot and wait for the archives to apply, which can be thousands and millions of them if you're very unlucky, right? And that is going to take some time. So the time to recovery, don't talk about recovering your database in case of crash. Think about the scenarios where your data is important enough that you have to bring the database back to the point where after which a catastrophe had happened, so that you could get the most amount of data back, right? If your business needs point in second, right, to the point, and I need it to be really quick, and I don't have more than an hour to recover the data back, or half an hour to recover the data back, then the solution, not all solutions which are there off the shelf on the operating system side, on the VM side, on the file system level, they will not make sense. So whenever you decide on a backup strategy, there are tons of them. It's like between Jan and I, we have 30, 40 years of working only on this kind of stuff, looking at various kind of solutions which are available on various technologies, right? But there is no one tool which can do everything.
And it's in that sense, this is a super interesting discussion because, you know, the question was by Gary, like, multi-terabyte database, which I think is one good parameter. But if you have a multi-terabyte database that has 5 transactions per week versus I got a 50 gigabyte database that runs at 40,000 transactions per second, I know of which of these two databases I would be the most worried. That it would not be the multi-terabyte database. And obviously, you're extremely right when you say, you know, there are other things, and I must admit, I approach this question very one-dimensional. If you have to take into consideration things like point-in-time recovery, you will need to have facilities, and it might be that doing one snapshot a day for a 40,000 TPS system is not a smart thing, and perhaps you do need to make one each half hour or something to have a viable window of being able to recover. Traditional RTO, RPO then come back to mind, right? And
yeah.
One thing is also true, a backup which is not tested is nothing more than a prayer. And we've seen that in practice too often. Yeah.
Too often, right? That is the key thing. It's like for whoever is attending, if you want to leave this discussion with one key point, just please write down what you want, what your needs are, what your needs are in terms of, you know, to meeting your SLAs, and then work your tools backward from them. It's like, you know, there is, as we said, there is no single tool or a strategy which covers all needs until and unless you are willing to pay somebody more than what exactly is the value of the data that you have.
Oh. And interestingly, also, most of these discussions somehow kind of come back to, you know, requirements. People, please look at your requirements. Don't look at features, don't look at implementation things, but as Deepanshu said, look at what do I want to achieve with my solution.
Yeah, follow.
Consider was kind of multi-terabyte, 10,000 plus transactions per minute, and application downtime not more than a few seconds.
Well, this thing is, you are better off with a delayed slave. That's all I can say. You can basically have a slave which is running a few minutes behind or a few seconds behind. That is going to be the closest. Even if you are going to go for so I think NetSuite allows you to do a file system level incremental backups, right? Which constantly can allow you to roll forward. But but for a multiple the size of scale, which is multi-terabyte database with 10,000 transactions per second, you can't recover in a few seconds. There is
especially the last bit of the question. Application downtime not more than a few seconds very quickly starts veering you towards, you know, I need something that is active in that sense, and then
yes.
Truly active, not active read write and active read, but a multi-master setup in that sense. Yeah. So basically you have two Postgres clusters that both run the same application workload and that are both available for write operations. Yeah.
Because even just to add, even if you have a slave which is a synchronous slave, and if it has zero delay, it can take up to 30 to 40 seconds to become and become a master, and it can go. It depends on the kind of what was the last transaction which it is replaying, you know, how big that was. So seconds.
You can obviously optimize a lot of that switchover functionality by using a containerized application environment, because that allows you to do it's not really sub-second, but it's 1 or 2 seconds to do a switch over between one master and the other. But the thing here is it's also the 10,000 transactions per second on this multi-terabyte database. And that, Deepanshu, to what you said, very much becomes true, that the database also needs the time to catch up. And then the other parameter, which is your recovery point objective, also comes in play. Can I just say, you know, I'm not going to apply these transactions and I'm going to activate the standby database regardless, right? If I lose the last 10,000 transactions or 20,000 transactions, because my recovery time objective is so much higher. If RPO is near to 0, what it mostly is, and then your RTO also becomes like 1 or 2 seconds, you really need to start looking at an active scenario.
Yeah, that is going to be the best thing to go about. This is a scenario which we have seen especially on highly say financial data kind of situations, right? And the customers have gone for a multi-master situation where they basically are, what the advantage of a multi-master to an extent is you can have a completely dormant master, right? That is, you can have the secondary master can just have its own application local to it. So you don't have the network latency problem. So if one site goes down, you can simply bring up the whole application and service it from another location altogether. So that can be relatively quick. It is going to be as fast as your ID administration can transfer the URL.
Yeah, and this is, I guess, as with many questions, right, that there is not just one answer, but as requirements become more stringent, the number of paths gets smaller, and especially I think this is one of the reasons why EDB adopted BDR as one of the solutions here. If you start looking at payment gateways where you absolutely are running on 0 RTO, 0 RPO, and when it gets to these more expensive transactions, like people transferring money from credit cards or other kind of bank accounts, it becomes imperative to have something that is able to kind of deal with those kind of challenges.
In a nutshell, the lesser amount of data loss which you want to suffer, quicker you want to do recovery, the more time in terms of monetary investment, as well as that is acquiring a hardware which is almost replica of where you're running the production, as well as having your infrastructure being resilient enough for monitoring. It becomes important. So that is where it is. It's going to be a fine balance for everyone to look at in designing the whole infrastructure.
And if you look at the entire path, in the beginning of this conversation, we started with developers that are running into Postgres projects that are actually being successful. So then when you start your first Postgres project, your first database, you don't even worry that much about backup recovery. Perhaps you just have, push on a button and you have a new instance of Postgres and you do an initial load of your test data. Then at some point you're actually getting users on the system and you want to start thinking about, perhaps I should have, this starter set available and do a PG base backup and PG restore just to test. From there, you start thinking, now I got more users on my system. Perhaps I should do something with PG receive all, where I start building an archive of my write-ahead logs to start thinking about point-in-time recovery. A next step would be perhaps I should build a standby database, which is super easy in Postgres. You set up streaming replication additional to your wall archiving, and at that point you actually have a primary and a standby database. At some point you think, I'm going to even open up my standby database for read operations. And actually there is a increasing path that helps you address increasingly stringent RTO and RPO requirements. that you can do with standard functionality that's available in Postgres. And then at some point, you start running into the necessity to start using tools. Deepanshu talked about backup recovery tools for point-in-time recovery and for other bits and pieces, up to a point where even if you're running like MasterCard, your mission-critical operations on Postgres, you start having requirements for tools like BDR, because you have zero downtime and zero data loss solutions that also need to be geographically distributed. So you need to run on all 4 continents. And the cool thing, it's all possible with Postgres, right?
It is. And the thing is, again, so that brings us to the important point again and again, which is basically like, when you're doing DevOps, if you are developing an application, look at the database as well. It's like you need to do something. You need to evolve the database as you go along. That is where somebody like somebody like an ADB or an expert can basically come in handy, where we can actually let you know the pitfalls of where you're going, because you don't want to be in a situation. This is my experience, right? Being in support, it is like being in a hospital. We only get cases which are when the people have suffered, right? I don't have positive experiences to share, except when the customer's issues are fixed and then they are happy, right? Nobody comes in happy to support. And primarily, one of the things which happens to them is like their application or the user base quickly outgrows the capacity to which they had originally designed the database for, right? And that is where the problems start. And it is almost like playing catch up at that point in time, because database is going to be working within the realms of the infrastructure which it is placed inside, right? Problem with Postgres, or disadvantage of Postgres, is you can launch it on a machine which is just going to have 2 gigs of RAM and basically a 1980s processor. It still works like that. It is because it was designed to be as light as possible. One of the things which I've read about Postgres, right? This is interesting, which gives you a context in the way it was designed. It was designed by students in an era where this memory was very expensive and this was cheap, right? So we created something which doesn't use that much amount of RAM or memory, right? That is why when you start your Postgres, you can, and you leave it to default, shared buffer parameter, which is one of the parameters which controls the amount of memory which the Postgres is set to 2 MB. So yeah, we think that is the design of it. It was designed in an era and where memory was expensive and storage was cheaper, right? As the things have evolved, memory is not as expensive as it evolved, right? So, but that does not mean that if you're going to put more load on Postgres, you would not need more memory. You would not need more CPU, right?
And this, that kind of brings us back to also where in the beginning, look at requirements, look at what you need to do, and then kind of make the Postgres solution fit to your requirements. And it's indeed good. And I think Mike Stonebreaker said that himself, those who forget the past are doomed to repeat it. So there is a lot of knowledge and a lot of experience around Postgres already available. And then the goal would also be reuse that information and reuse that to move forward.
Right. So that is where it is going to be highly important for DevOps to include Postgres into their development plans as well. It's like, are we hitting the limits of what we have at the lower end, right? Because so this is another experience of mine, right? So there is a customer of ours who is basically he is extremely smart in terms of modularizing his application, right? He doesn't do everything in one place. He doesn't develop application in one big chunk, right? Like the modern way, it is like he divides it into different modules which go live at one point or the other time. He outgrew the database capacity. They initially had decided that the database they were going to be considering to be handling around about 200 to 300 parallel connections at any given point in time. And at some point in time, that information got lost. And at the end of it, when they came to us, they needed around about 1,000 connection capacity through the database. And then there is no infrastructure. The infrastructure was a hard machine. It was a physical machine, which could not be upgraded. So they had, the problem was, you cannot, you have a machine which is slightly older with limited upgradable memory on it, with limited ways of improving the throughput of your IO, because your disks are SATAs, right? Maybe if you need to put in SSD, solid state storage, right, you'll have to configure a NAS on it, but it still needs some amount of downtime. You're going to move the data from your physical disk to a different storage type, right? So there was no easy way out for him, right? And he had to bite the bullet and take an outage. That cost him money, right?
This kind of technical debt is unfortunately something we do encounter every now and then. Yeah, absolutely.
Right. So that is where it is. Just being aware of what you are doing at all times, even in terms of the lowest part of infrastructure. There was one more interesting situation which we had some time back, right? So the customer was already on cloud, right? Everything is running beautifully for him, and he realized that the high availability failover time was too high for him, and this is in cloud, right? So he has one cloud instance, and then the second one which is doing the slave, and the replication is going on, right? And there was a condition in his contract which basically asked him that he had to reduce the switchover times to under 10 seconds. The fun thing is that is the kind of architecture which he had is a non-synchronous architecture. And his application was doing more than 60,000 transactions per second. So at any given point in time, there was 20-second lag.
And that's a little bit, yeah, what we discussed, right? You can technologically perhaps get to quick enough times, but if the load on the database, and that kind of is, I think, also being mindful of the time, a very nice call to kind of conclude with. Look at your requirements, look at what your system needs to do, look at what it is projected to do in the future, right? God forbid that your Postgres project is successful and you actually have to start doing real work on the system. Look at requirements, look at what you need to do, and kind of orchestrate your environment to really do it, because in the end, Postgres will be with you until the very end to do the work that needs to be done.
Right,
with that,
right technology partner is going to. Sorry, I just.
Absolutely, that goes without saying.
Yeah, just wanted to reiterate that you just recognize the need of knowledge.
Yeah.
Just recognize the need of knowledge, so that you have access to it when you need.
That I think that's the perfect bombshell to end this session with. Thank you. Thank you, Deepanshu. I think, Monica, this takes us to the end. I don't know if you have any closing words for us.
Well, thank you very much for sharing your deep knowledge with all of us, and it has been very insightful, very interesting. To all of our attendees, we will be sharing the recording of this session in the next 24 to 48 hours. So look out for emails coming from us. I am sharing with you also the link for our upcoming webinars, which are 3 educational series on BDR. So check out those and register, because spots are limited. And again, thank you very much, Jan, and thank you, Deepanshu, for your time and for this insightful session. And well, I'll see you everyone around.
Yes, thank you. Thanks for having us.
Bye.
Bye.